Yo, what's up guys? It's Salah here again today, and today what we are going to learn will be about fundamentals of programming. We are going to do a question in math, and then third what we are going to do is going to discuss some stats. What we the stuff we did in stats in today at the university. So first in fundamentals of programming, what we are going to learn, it will be about value. What we learned today at the university was about value and reference parameters. Value and reference parameters, and then we did an example program of this topic at the university, which I'm going to discuss as well. Then secondly, in math, we discussed right and left hand limits, uh, and we did two questions related to this topic, and I'm also going to do a sample question so you guys better have an idea what is the right and left hand limit. After that, you guys will be able to solve that problem which I'm going to solve after I'm done with this topic. And then third, we are going to discuss the sampling distribution of mean, and then we are going to find the sampling distribution of variance, and then we are going to make an inference from that sample variance, the inference of the population variance, and then we are going to compare whether the sample variance is equal to your population variance, and that will be our inference that covers our inferential statistics. So I hope, and let's hope, that we can cover all of these three topics in this video. If not, I'm going to make another video for the topic we have skipped. So first we have value and reference parameters. So we have two types of parameters. We have value parameter, and then we have a reference parameter. So for in every every value parameter and reference parameter has first, let's say we have a formal parameter. Firstly, we have a formal parameter, and we have an actual parameter. Same here, formal and actual. So we have these two parameters. Formal parameters is the formal declaration, the parameters which you use in when you are declaring a function, when you are writing the function heading, then the function body. So the parameters you use there are called general parameters or your formal parameters. The parameters you use when you call a function inside another function, those parameters are known as actual parameters. So what a value parameter is, when you call a function and then you insert actual parameter when calling a function. So in every function call, formal parameters get replaced by your actual parameters, means that the values of your actual parameters are copied into your formal parameters, and each formal parameters receives a separate copy of your actual parameters. So for example, you declare a function. For example, I declare void, a non-value returning function. I say that this is function 1, and here I declare I declare the int. I say int a and int b, and then there's a function body here. There's a whole lot of code inside, and then when I call this function, and then I'm going to obviously write the prototype of this function, only the function heading after your hash include, before your function main. And then when I'm going to call this function, I'm going to write fun1, the name of the function, and then I'm going to write the parameters. For example, I said that is x, and y. So these two parameters are, these two are actual parameters, and these are the a and b are general or for your formal parameters. So whatever the value of x and y will be, these values will be copied, means these values will be copied inside these formal parameters. So that means that in the RAM of the computer, a will have a separate memory space and b is going to have a separate memory space, and these two already have separate memory spaces, x and y. So for example, you insert or you put an, or you know, this variable has a is a type of integer. So you have, for example, you insert 5 here and you have 7 with y. So each corresponding formal parameters will have a separate copy, will have a copy of your actual parameters. So a will also have 5, a will also uh, contain 5 in its memory location, and b is going to contain the corresponding actual parameters value, that is 7. So that means now you have two memory locations of the same actual parameter value. You have two memory locations of 5s, and you have two memory locations of 7. So that means once the value is copied into your actual into your formal parameters, these formal parameters are going to manipulate your data, which they got from your actual parameters, and then they will have no connection with your with your actual parameters. It means whatever happens to these memory locations, means that whatever formulas or whatever happens to these values right here is not going to affect your actual parameters, because they contain separate copies. It's because this has a separate 5 and this has a separate 7. They have their own copies of your of the actual parameters, so they have no connection with your actual parameters after the values are copied. Now coming towards your reference parameter. So in reference parameter, this the formal parameters don't actually receive a separate copy. So what happens instead, they receive an address to the formal parameters value. So for example, x is 5, they don't receive a copy, so they don't get a separate memory location inside the RAM. So you have x, so for example, the values of x and y are same. So x is 5 and y is 7. So these values are not going to get copied inside your actual inside your formal parameters. So what happens instead, they get an address, so they are being referred to your actual parameters. So the value of these formal parameters is going to be the same, but instead of the values being copied inside your formal parameters, they actually are being referred. The formal parameters are actually being referred to your formal parameters for the values. So that means the address, the address of your actual parameter is going to be your address of your formal parameters. So that means the addresses are going to be the same, so the values are also going to be the same. So it's going to refer right here, and b is going to refer right here. So that means they don't get separate memory spaces inside the RAM. They just get referred to the values of your actual parameters, and then so they use these values, so they use these memory locations for to manipulate the data, whatever data is inside these memory locations. And when they manipulate it, they actually change the data they actually affect your actual parameters because they're using these memory locations and they're manipulating these datas inside the function. And when and during the process, as the data is getting manipulated, these values also keep getting changed because it is referring and it is using these memory locations instead, where we had value parameters where you had separate copies, so they had no connection. But now, right now, they have a connection. So whatever happens to the parameters, to the former parameters inside the function, is also going to affect the actual parameters when you call a function. So that was about value parameters and reference parameter. And also let me how you can so let me tell you how can you write the syntax of how can you differentiate between a value parameter and a reference parameter. So how you're going to do that, it's pretty simple. So in a function call, the function calling process is the same, but the difference comes when you declare the function. So when you declare the function, if you want a variable, if you want a parameter to be a reference parameter, what you're going to do is after declaring the so for example here, after declaring the data type of the variable, what you're going to do is put an ampersand sign after the data type. So that will so the compiler is going to identify that right here this is your reference parameter. And when you don't put an ampersand sign after your data type, so the compiler will know that that is not a reference parameter. So if it is a reference parameter, it's the formal parameter is just going to be referred to your actual parameter, and the values will keep getting changed as the data keeps get manipulated. But when it's a value parameter, they receive the the formal parameters receive a separate copy, and the values, and then they have no connection with your actual parameters. So actually we did a program at the university regarding this, but I think I don't have much time to do the program. So instead what I'm going to do is jump right onto your right and left hand limits and solve a question related to your right and left hand limits. So here I have the questions we did at the university. So here I have a question. Here I have a question that what I have to do, I have to find the values of a and b, where f of x equals 1, x plus b, and 7 if your x is less than or equal to 3, your 3 is less than x, and x is less than 3, and x is x is greater than 3 and less than 5, and x is greater than or equal to 5. So now you have to find, so here you have to find the values of here you have to find the values of a and b. So if this function is continuous at let's say if this function is continuous at 3, so okay, I'm myself confused in this question. So also in the question, in the question it is given that this function is continuous at a certain point, but it's not given here. But the way you solve this question is first you get to know that at what point this function is continuous at, and then you apply the left hand limit, then you apply the right hand limit, and if the limit exists, the right hand limit is got to be equal to your left hand limit. And then when you compare the values of ax plus b with this with whatever value you get, uh, if, and also a thing to remember, if it's a left hand limit, so that means it will be less than x. If it's a left hand limit, it's coming from the left side, so it's approaching from the left side, so it's going to be less than x. But if it's approaching from the right side, that means it's greater than x. The value is greater than x. So these two things you guys need to remember. Inshallah, tomorrow I'm going to bring some questions regarding to, actually today I don't have the book, so inshallah tomorrow I'm going to bring solve some questions regarding to your this right and left hand limit. So for now we are going to skip this. So, and now we are going to jump right up to your stats, and that was about sampling distribution. Sampling distribution of variance. Sampling distribution of variance means sampling distribution. First, what we did, we did the sampling distribution of mean, and then we found out the variance. So what we are doing right now in the university in the class is we are doing inferential statistics, where we make inferences of the population from a given sample. So right here, we had data. We had a data. So what we had the prices of n objects, which are these. We had 23, 25, 26, 28, 30, and 24. 30 and 24. So first what we did, we found out the sampling distribution of mean of size n equals to 2. So what that means is we took two samples from this. We took the samples of size 2 from this data set, and then it can be 25, 28, it can be 25, 30, 25, 30. It can, all the samples you can make of size 2 from this data set. So we did that. We found out the mean of these samples by just adding all the two terms and dividing by 2, and that gave us the mean of every corresponding your distribution. So it gave a list. It gave us a list of all the means we got from our sampling distribution of mean. So after we got the means, what we did is you actually have, for the population variance. For the population variance, you have the formula variance of x equals summation of x bar square f of x minus x bar f of I'm not sure myself if this is correct or not. I'll have to make sure, and I'll confirm it in tomorrow's video, that whether I was right or wrong. So this is the formula for the variance of x for the population. For the sample, you have the formula sigma square equals summation of x minus x bar, and here it's I equals n and n equals 0, and x minus x bar whole square divided by n minus 1, and here here I equals 0 and it's n. It's n, I equals 0 and n minus 1. Yes, alright. So this is the formula for the variance of a sample, and also the sigma square, and this is the formula for variance of the population. So, in this inferential statistics, what we do is actually we make inferences about the population from a given sample. So what we did from the mean, so what variance is, it actually tells you the individual distance of each sample point from the mean on the average. So once we got all the means, we found out the of the samples. We found out first. So first we found out the population variance by this formula. So we took every mean, we squared them, and then we multiplied it by the corresponding probabilities, and then in the second here part here, we multiplied each mean from its probability, and then we took the square, and then we differentiated, and we got 1.11, I think. And then with this formula, we got uh, and with this formula we got an answer. And then what we did, we put this formula in this formula, sigma square divided by n minus n divided by n minus 1. So once we put the answer we got from this formula into this formula, so this is your sigma square, this n is your total number of total number, n minus 1, n is your sample, small n is your sample, and variance of x was your 1.11. So once we put this sigma square into this formula, actually we got the same 1.11. So this makes sure that, so this proves that sample variance, our inference about the population variance from the sample variance was correct. Alright guys, thank you very much.